Gentlemen, lines and angles, section 3.1. All right, we are moving into chapter 3. Skipping chapter 2. Chapter 2 is all on proofs, which again is kind of like old school geometry. We are now into the new school geometry. What's up, sir? Pull it up. I'll show you. Okay, so lines and angles, section 3.1. A lot of vocab today. Not really a lot of math per se, as in like adding, subtracting, and such. But vocab really is what's going to be on today. Okay, kind of having to identify and understand some different terms. Okay, so lines and angles, section 3.1. Again, feel free, freshmen, to pull this up on your iPad. If you download it into certain apps, you can just write on your iPad. You don't have to write anything down. But again, you have to, no, not Flappy Golf. Okay, thank you. You open it if you're at the top there. You have to have certain things. You have to have certain apps. You have to have certain apps so you can download it into. You probably don't have any apps yet.
I do.
All right, so lines and angles. Vocab here. We're going to talk about parallel lines. Parallel lines are lines in the same plane that do not intersect. Again, the key there is they have to be in the same plane. Lines in the same plane that do not intersect. Everybody knows parallel lines as, oh, there's lines that never intersect. Well, true, but technically they have to be in the same plane. Because there are an example of, we'll talk here in a bit, but skew lines. Different. So example there of parallel lines. If I have a line here and a line there, those are parallel lines. If you look at the creases in the front of the room, the walls, think of those are lines we talk about a lot in 3D space. Those lines would be parallel. Okay. A lot of times they'll denote parallel lines. They'll put an arrow on the line showing they're parallel to each other, just like almost like a congruency symbol. But they'll use arrows going the same direction. Those are parallel. Perpendicular lines. Lines that intersect at 90-degree angles. So lines that intersect at right angles. So if I have a line here and a line there, usually those are denoted with a square or box in the corner, like we see. Okay, next one, skew lines. Lines that are not coplanar. What's it mean to not be coplanar, Troy? Not coplanar. What's it mean to be not coplanar? Not in the same plane. Very good. So this is kind of tough to do on a 2D plane here. But if you look at, our walls up here. Okay, if I think of, this line right up here in the front of the room, there are crease up where our walls meet. Okay, if that was one of our lines, and then the way back where the ceiling and the wall meets, that's our other line. Those are skew lines. They're not parallel, they're not in the same plane, and they're never going to intersect. Those would be skew lines. Same thing if I went that crease, and the one over here by the wall and the carpet, that line. Okay, there's all these lines that don't intersect. Those are skew lines. Okay, and then parallel planes, planes that do not intersect. So if you look at it, it'd be like the floor and the ceiling. Those are two planes that are never going to intersect. The front wall and the back wall. Those planes aren't going to intersect if you keep going and going and going. Okay? And then lastly, we have a transversal. Now, everybody always forgets what a transversal is. Transversal is just a line that intersects two coplanar lines. So transversal is nothing more than, if I have two lines, it's a line that crosses them both. That's all a transversal is. Okay, but every time we ever talk about this, everybody always gets confused because they start throwing out this term transversal. And it's, well, what's a transversal? It's nothing fancy. It's just the line that cuts up two other lines. Okay, I can have a line like this, and that's a transversal. Okay, it's anything that cuts up two other lines. All right, so that's a transversal. Freshmen, you should know these terms a lot. We talked about these a lot last year, getting ready for NISA test. But corresponding angles, for two lines intersected by a transversal, a pair of angles that lie on the same side of the transversal on the same sides. Corresponding angles are just really same position angles. Okay, I always say they are same position. So if I look at it here, if I have a line there and a line there, cut up by a line, those two would be corresponding angles because they would be both technically like top left. If I were to break this up into, the four areas, if I look at those four, I have the top left. And if I look at those four, it's in the top left. Okay, so they're in the same position, just on the different lines, technically. So those are corresponding angles. The next one we have is alternate interior angles. Alternate interior angles are a pair of angles that lie on opposite sides of the lines. So they lie on opposite sides of the transversal and between the other two lines. So really, I always break it down. Alternate interior angles are different inside angles. So they're on different sides of the line, both on the inside. So if I look at that here, cut it up, there's my lines cut by transversal. Alternate interior are those type of lines right there, those type of angles. Okay, they're on either side of the line, both on the inside, smashed between our two lines. Alternate interior angles. Then we have alternate exterior angles. So same thing here, cutting up my line. Well, alternate interior means inside, alternate exterior means outside. Okay, so an example of alternate exterior would be those angles. Taking them both on the outside. And again, same thing, opposite sides, both on the outside of the two lines. And then the last one, we have same side interior angles. Well, same side interior angles is just how it sounds. If I have two lines cut by transversal, they're on the same side, both on the inside, something like that. Those are same side interior angles. So again, the key there is just understanding the terms. And that's what we're going to be doing today. We're just going to be identifying and recognizing some different pairs of angles. So not really a lot of math, but it is the vocab. You ready to move on? Good. So if you look at the next one here, just further examples. The parallel lines, talked about it already, but they use the symbol there. Okay, if you look at the symbol, there's the symbol for parallel lines. It almost looks like an 11. A lot of times they use a diagonal with it too. They'll go diagonal parallel lines to just denote it a little bit better. But those are symbols that are used. Same thing for perpendicular lines. Looks almost like an upside down T. Okay, you can identify perpendicular lines by putting it as an upside down T. You're going to be able to recognize that so you can read it within problems and such. And then skew lines, there's nothing special for skew lines. They just say they're skew. Okay, so if you look at that, K and M are skew. Nothing, no special symbol or anything like that, but just kind of recognizing that they are skew. Okay, so let's look at the first problems here. So number one, I'm looking at this diagram to the right, and I want a pair of parallel lines. So as I look up there, I have three lines. If you can't tell, there's line J, line G, and line H there. Okay, so line J, G, and H. And I want a pair of parallel lines. If I look up there, Jack, which of those lines are parallel? H and G. So I'm going to say H is parallel to G. That's all it is. H is parallel to G. What about a pair of skew lines? Now this is always the toughest one, is identifying the skew lines. Now again, skew lines, they're not parallel, but they're not going to intersect. So not parallel, but they're not going to intersect. So what are two lines that are not parallel and are still not going to intersect? What do you say, Caitlin? G and H we just said were parallel, didn't we? Well, at least you're honest. What do you say, Ryan? What's an example of skew lines? J and H. Very good. Because J is going up and down. H, they're not intersecting and they're not parallel. All right, number three. A pair of perpendicular lines. If I look at perpendicular lines, I'm looking at what, Kendrick? What are two lines that are going to cross, meet 90-degree angles up there? Very good. So G is perpendicular to J. Nice job. Same idea now. I'd like you to try these 6. So take a couple moments here, try these 6. Identifying segments. Number 4. A segment that is parallel to DG. There are 2 of them up there. What's one of my parallel segments, Max? HE. Now, notice, please, I know a lot of us are getting these wrong right now. I say HE, but I need to make sure I put my segment above it. Okay, if you not put the segment, that is wrong. So I need to make sure I put that above that. Does anybody know the other segment that's parallel? F what? J. FJ, good work. Now, number 5 is to the right there. What's a segment that's perpendicular to GH? There are 1, 2, 3 of them. There are 3 of them perpendicular to GH. Give me one of them, Anna. What? Yes. HJ is perpendicular. Good work. Another one could be HE again. And the other one could be DG. Good work. Number 6, a segment that is skewed to JF. What's a segment that is skewed to JF? So not parallel, but they're not going to intersect. Keegan? EH would be parallel, sir. Because they're in the same plane. Instead, what do I say, Troy? HG would be skew. Okay, because that one's going this way and that one's going up. So those are going different ways, in different planes. What about number 7? One pair of parallel planes. What's an example of parallel planes here? What do you say? Trevor, you think you got that one? Well, do you all see which ones are never going to intersect, those 2 triangles?
Yeah.
Well, we label them with 3 points. So plane DEF and plane GHJ. So I'm talking about that plane right there, and I'm talking about that plane right there. Yeah, because there's not giving us a specific letter for the plane, so you indicate it with 3 letters that are on that plane. Okay. Number 8, one pair of perpendicular segments not including GH. What do you say, Noah?
I said EH and FE.
Nice job. EH and FE are examples. Good work. And last one pair of skew segments not including JF. What's an example of skew segments not including JF? What do you say, Troy? That's a good one. ED and G. Which one? No, not GH. How about GJ? GH would be parallel, bud. GJ, though, would be skew. You see how GH would be parallel?
They can't be parallel.
Skew is not parallel, bud. Okay? So, yeah, recognize that skew. Skew is not parallel. Next one here, types of angles. Again, we talked about this. Here's just further examples of everything we're doing. Corresponding angles, angles that lie on the same side of the transversal and on different sides. So if you see that here, same position. We talked about that, same position right there. Alternate interior, so different sides of the line, both on the inside. Alternate exterior, same idea. So different sides of the line, both on the outside. Then we have same side. So they're on the same side, both on the inside. So same side interior. All right, we're going to look at a set of these lines and try to identify some of these different types of pairs. So number 10 here. Looking at that, those 3 lines. Okay? I want to name some corresponding angles. So corresponding angles mean they're going to be in the same position. Troy, give me one of them. So I'm going to say angle 2 and angle 4 is correct. Because again, both those would be like in the upper right side. Okay, those would be corresponding angles. What's another example of corresponding angles, Catherine? 1 and 3. Nice job. What's another example of corresponding angles, Camden? Angle 5 and angle 7. And there's one other example of corresponding angles. Who found it? Nice job. 6 and 8. Good job, Jess. What about a pair of alternate exterior angles? I'm talking about different outside angles. What's an example of alternate exterior angles, Nick?
Angle 5 and 4.
Angle 5 and angle 4. Good work. There's one other example of alternate exterior. Troy? Angles 1 and 8. Freshmen, are you like, hey, we did this a lot last year? Know this already?
We did a lot of X.
NISA test? You betcha, man.
Got me on this guy.
Number 12. Same side interior angles. What's an example of same side interior angles? Anna? No, because they're not on the same side. Not 2 and 6, but how about 2 and what? Angle 3, very good. 2 and 3 are on the same side of the line, both on the inside. Those are same side interior. What's another example of same side interior, Camden? Good work. And last but not least, we have alternate interior angles. Give me an example of alternate interior angles, Ryan. Angle 6 and angle 3. And angle 2 and angle 7. Nice job, Jess. And that's it. So again, today, is that really a lot of math? No, it's just kind of identifying some different angles and such. Here is your assignment.